Well, before I just do things and repair them and not make a video, I thought this would make a good video. These are 700 pint dehumidifiers, and the problem was we would come out here and this circuit was blowing. Let me demonstrate for you right now. I think just turn it on. Boom. See that fraction of a second it took? It wasn't instant, but it did happen fast. So what I did was like, okay, without looking at the schematic, this is on the 24 volt circuit. I just pushed it in, it reset. I can actually hear the click when it resets. Your ear can tell you something. Okay, so this is only a continuation of the switch right there. This fuse is in series, and so if you see it looped over, you can see how it is. It just goes up and then it goes through here, the fuse. It comes back and you follow the pink wire. The pink wire goes to this board. The board is commanding something to turn on. Well, you see two relays here. You know, sometimes relays get stuck. If you're on a furnace, a blower doesn't come on, you tap on the relays, there might be a little bit of oxidation, or they stuck and they didn't close all the way, and you just jostle them enough by tapping on them, and all of a sudden your blower and your furnace comes on. Okay, so then you go over to the pink. So the pink goes here, you look at the yellow goes around, the yellow makes a little bend, it comes down here. It's the other half of your 24 volts, because this is on the 24 volt circuit and that's what's blowing. So then you follow the 24 volts, and if you follow, it's making a U over here, it's coming up and it's going to the circuit board. So all I did was I said, okay, what if I take one of these off? Now I'm just purely guessing. This is called just fly by the pan of your seats, just guessing with a little bit of experience to see what's causing a short. So I turn it back on and you'll see it doesn't pop. So we're using no schematics, and we're using no knowledge, and we're not using any gauges or any meters or anything like that. Okay, it didn't blow. So let's unplug the other one, plug this one back in, because the signal goes out and it goes to things to activate it. Okay, we're still on. We did not blow. Now I know when I plug it back in, within 3 seconds it pops. So there's a lag, there's a delay. So the next thing I did was I go, okay, well, I pulled out, just in case, and you see that's a call for something else, and I think that something else is for the compressor. Now it's time for the compressor to come on, but it won't because I have this unplugged. So I said, okay, something in the 24 volt circuit is nearly like dead ground short, and it only comes on after a delay. So it's, in my mind, it's an activation device, some device that activates something else to come on. So your 24 volt system, what does your 24 volt system activate? Well, it activates a contactor, and it activates, here's another little relay, you know, like a contactor, same thing. So there's two things that get activated in here. This is nothing more than a capacitor, and if you read down there, you see 6 right there, you can see, come on, focus. So you see that's a capacitor, so you don't have to worry about that being in the 24 volt circuit. So you go, wow, what are these things? So they got, for safety and I guess short out and voltage spike suppressions, they got thermistors inside here. So I pulled off a thermistor, and the thermistors are not grounded. They're in the mega ohms, you know, they're like way out there, and that's what they should be, because they're for suppression, spike suppression. So these are okay. When I pulled each one individually off and I went from terminal 1 to terminal 2 just through this, it's open, so that's fine. So then what I did, I said, okay, what do we have in the 24 volt circuit? We only have 2 items left in the 24 volt circuit. If there's no wires that are grounded out and touching metal anywhere, you don't see any wires rubbing together, like those wires that are real close to there, like say they were vibrating because the cabinet was vibrating, and it was like going right through the insulation and grounding out. So if you don't see any of that anywhere, and this is a new unit, it's only like 2 months old. So 2 items, what do we have? Coil and coil. All we do is we have electromagnets. There's nothing more than a little coil of wire that has a resistance going through it, I think of around a nail. When you were in grammar school, your teacher showed you a 6 volt battery, and he got like a 16 penny nail, and he wrapped copper wire around that 16 penny nail, and he put one side to the positive and one side to the negative. Remember the big 9 volt or 6 volt battery that had the picture of the cat through it? Okay, most of you aren't old enough to remember the batteries with the cat picture on it, but your teacher did that, and he'd go to something steel and it would pick up anything steel. It turned the nail into a magnet. That is all what a coil is activated by. It just makes a magnet and it pulls contacts over. So because they made out of steel, they have steel with little copper faces on them. It just pulls it over to touch to make the 110 or 208 or 240 volts go through and complete its circuit. So that's telling me, a coil must be shorted. So I came down here and stop going out of focus. Come on. Focus, focus, focus. Okay, I gotta move my camera because my camera is not focusing. Windows last update, the last 2 updates ago, messed up iPhone 6, 6 Plus, 6 Plus S. Everybody who has an iPhone 6 is noticing that their cameras aren't working so well. A lot of people are having problems, and it came after an update. And so that's Apple screwing with you guys, trying to say, oh, my camera's getting old, I must have to go out and spend $1,000 to get a new one. It's the software. All right, so now what I just did was I took this off, and because I wanted to make sure that I already tested this individually. We're on right here. Let me get light on so you can see it. Okay, you can see it. Let's see if I could do this one-handed. One hand here, one hand right there, and come on, damn it, 13.5 ohms. Can you read that? 13.5, and can you see the flashlight's killing it? But if you could see far over there right, you see the ohm. You could see the ohm reading, 13.5 ohms. So that has a little bit of resistance, and that's about right where it should be for this little puppy. Okay, so there's only one more left in the circuit. So we'll pull that one more out of there. There we go. So if you see right there, and if I could zero in on that so you can see it, that is a symbol for a coil, a magnetic coil. See that little symbol? It's not a diode. You would think a diode. There's no diode mark in it. That's just a coil. You have the same thing when you see the schematics on some of these, on the contactors. When a contactor has a coil schematic, you'll see the little coil schematic on there. Same right there. So it's nothing more than a wire wound around a little piece of steel that makes a magnet, and when you have a piece of wire that is round, it has a certain amount of resistance. So let's put one, and we're having the one-handed problem here. Let's put one there and one there. Okay, so we're touching right across that coil. What do we have? 0.000.0 ohms. We are straight up ground. Now did you see that K, and then you mega ohms, and then out of limb, see we're open in the air. Now watch this. 0.0 right across the steel from here to there. Same thing. If I ground them out and touch them with my fingers, 0.0. So our coil failed, and it's now a direct ground to each other. It's turned into a molten piece of a solid rod of copper inside there. So that was it on that, and that's why this unit won't come on. This particular relay is for the fan inside here, not the motor, but the actual fan. This is your high current relay, so this will be for your compressor motor, and this is a low current one, and that turns on the blower fan inside here. Using no schematics and on a 24 volt circuit only. And if we see, here's what we'll do. We'll plug this back in. Remember, when these two of these are plugged in, this would blow. Hey, we're not blowing. Okay, and we're hooked up here. So you could go through the series of elimination. you're going through a sequence of elimination. If I had this plugged in and I pulled out my wires from my 24-volt coil that energizes the contactor and it doesn't blow, then you know this is still good. So now I'm gonna connect this in, and let's look at, watch the fuse, and yeah, my finger can see that over here. Let's connect this up. Pop. Did you see that? It popped out. That's it. So without using schematics, I mean, basically, you didn't even need this. You just through the process of elimination with no expensive tools and without jumping anything, without any danger of you don't know what you're doing and you're trying to jump things, and if you do something wrong because you didn't look at a schematic and you really don't know how something operates, you can damage something. You never want to jump out things you don't really understand. So in this whole process, you never see me jump anything. I only used the circuit what was here and just connected and disconnected. There was no jumping going on. It was a process of elimination. So that's it. So we'll get one of these. We're not going to wait for it. It's under warranty, but they can't afford to be without this piece of equipment for warranty. So we'll pull this off, run down and grab another one, get them up and running, call the warranty, have them send another one out here, and we'll have another one probably put it inside the cabinet or mount it on the cabinet or something, so it's a permanent replacement just in case it ever goes bad again, because the cost of downtime is more valuable than the part is. That's it. See you guys later. Process of elimination, no jumping, no tools. The tool was just to show you that there was actually a short inside of that little relay right there. See you guys.